So let's try our example. Example here, a symmetrical vertical summit curve has tangents of 4% and negative 2%. So it means that it has a back tangent and forward tangent in arrangement. So that's back tangent 4% and forward tangent of negative 2%. The allowable rate of change of grade is 0.3% per full station, and our full station is 20 meters. Stationing and elevation of PT is at 12 and 020 and 142.63 meters respectively. Compute the length of the curve, location of the highest point of the curve from the PT, so that would be S2, and the elevation of the highest point. Okay, so first is what we're gonna do is we're gonna draw the figure. First is let's draw the 4% and 2%. So say for example, this is the 4%. So this is G1, which is 4%, and I'll call this as the vertex, and I'll call this as the PC. And then I have here the negative 2%. So we have here. Okay, so this is G2 as negative 2%. Okay, how did I come up with that 2%? So it's 2 as the rise and run as 100. So something like this one. G1 is 4%, so it means that it is at 4 over 100. So 4 meaning this is the rise and this is the run. So something like this. So this is the 4 and this is the 100. And then for the G2, it's negative 2%. So that's 2 over 100. And this is the rise over the run. And something like this one. 100 and this is 2. Okay? So, ginana nato siya pag understand. And let's try to label this also, that this is at the PT. And then I'll draw the curve. So okay, say for example, okay, all right, so in this case we'll have this length from this position towards here. This is the length of L over 2, and from this position towards here and towards here, this is also our L over 2, and this whole length and here until here, this is our length of the curve. Okay, so it we were asked to solve for the length of the curve. How do we solve for the length of the curve? If the given is the rate of change of grade, so the rate of change of grade is equal to the G1 minus the G2 over N. So if ever magani negative yung mong answer, all you just remember that the difference of slope or the difference of the G's should not be a negative value. It should be a real value. So therefore, you must take the absolute value for that. And with that case, we're going to substitute everything. R is 0.3%. Okay, so that would be 0.3. And that's equal to, and that our G1 is 4%. So we'll have 4 minus negative 2% divided by n, and this would be n equal to 4 minus plus 2 over 0.3, and then n now is equal to 6 over 0.3, and n is, we have 6 divided by 0.3, that's 20, n number of stations. So therefore the length is the full station times n. So what is our full station? Our full station is 20 meters and the n is 20. So therefore the total length is 400 meters. And that L over 2 is equal to 200 meters. Alright, so we can have here as 200 and 200 for L over 2 and 400 for L. Okay, now we have to solve for the location of the highest point from the PT. Okay, so from the figure, although it's not that scaled, but probably na diri malocate na to ang highest point sa atong curve. So let's say that's the highest point sa atong curve. So what we're going to do is we're going to locate this point from, ingon sa problem that it must be located from the PT. So we have to locate it from the PT, and that is S2, no? Because the distance towards PC is S1. Right, so how do we solve for S2? So S2 is equal to G2 L over G2 minus G1, no? And that would be 2% 2% times L, which is 400, over 2, no, asa man ang negative, ano niya, buta na to ang negative. So this is negative and this is negative 2 minus 4. So S2 is negative 2 times 400 divided by negative 2 minus 4. So that's 133.333. So 133.333 meters, and that is the location of the highest point. Okay, so that's the location. Location meaning that's in meters. And then we are going to find the elevation of the highest point. So remember that the given elevation is at elevation of the PT, which is 142.63 meters. And then we are going to find the elevation of this point. So how do we solve for that elevation? So what we're going to do is we're going to transfer, no? We're going to transfer the elevation. So if this is the elevation of PT, and in a certain level this is the the location of the highest point, this one, here, this is the location of the highest point. And if I'm going to make a vertical line, I'll have a distance y here. So if that y is intersecting at this point here of the tangent line, so I'll call this as point A, then the elevation at point A would be as the same with this elevation horizontally, because elevation is measured from the baseline towards a position or a point. Okay, so say for example, so this here, all these points here represents the elevation of point A. So meaning this is also elevation of A. So to get elevation A from PT, all we need is a distance from PT towards A. No, vertically. Something like that. No. So I need this distance Z so that I could add that distance Z towards this 142 so I can get elevation A. Once I have elevation A, it's also the same elevation here. Then I'll be deducting that Y to get this elevation HP. No? So I'll repeat. We need elevation A. In order for us to get the elevation A, we need the elevation of 142.63 plus the Z. That's elevation A. And to get elevation of the highest point, we need elevation A, and then from the figure, we're gonna subtract Y. No? So we need the elevation A, we need the Z, and we need the Y. Okay, so by simply looking at this figure, we will have a triangle. So solving for the Z value, okay, so with this triangle here, by the way, this distance here is S1, and this grade here is G2, which is 2%. Okay, so by the principle of slope, or concept of slope, that it is equal to the rise over run, it's understood that the slope is 2% and the rise is Z and the run is S1. I mean, not S1 but rather S2. Okay, so we're gonna convert 2% into its decimal orientation. That's 0.002, and that's equal to the Z over S2, which is 133.333. Therefore, we can solve for the Z value. So what is the Z value? Z value is 0.002 times 133.333. So that's 0.267. 0.267 of a meter. So that's our Z. Next is we're gonna solve for elevation A. So elevation A is equal to elevation of the PT plus the Z. So what is elevation of the PT? 142.63. So 142.63 plus 0.267. So that's 142.63 plus 0.267. 142.897. Okay, so that is elevation A. Next is we're gonna solve for this one, y value. So how do we solve for that y value? So by principle of um, proportionality of parabolic curves, no? So gonna have this one. So let's copy this. Let's have the squared property of parabola from our solid mensuration or geometry. So gonna have this figure. So I'll delete some of not included. And this one. So I'll just delete this. Okay, so we're actually looking at this figure. Remember that from the vertex there is a maximum offset distance. From the vertex there is a maximum offset distance, and I'll call this as the h. So squared of property of parabola states that the ratio of the offset distance, h over its square of its length is equal to the same proportion of its offset with the same slope over the location, the square of location. No? Or that's from y over x squared, and that's equal to y1 over x1 squared. This is from your solid mensuration or geometry. So we're just actually applying it in the surveying. So h, we don't have h. So what we're gonna do is we're gonna solve for h. So h is L over 8 g1 minus g2. So L is 400 over 8 times 0.004 minus negative 0.002. So you have h equal to, that's 400 over 8 times 0.004 plus 0.002. So that's 0.3 of a meter. So now we can solve for the y value. Let's copy that and paste it here. Our h is 0.3 over L over 2, which is 200, and you square that, it's equal to y value, which is the unknown, over 133.333 square, and y value is 0.3 times 133.333 square over 200 square. That's 0.133 of a meter. So therefore, we can now solve for the elevation of the highest point, and that's equal to the elevation of A minus the y value. Elevation A is 142.897. So 142.897 minus 0.133. So elevation of the highest point is now 142.897 minus 0.133. So that's 142.764 of a meter. So that's the elevation of the highest point. Let's proceed to the next one.